start speaking.
And then when I'm done with this, I'll hand this one to you.
Thank you.
And remember that the presentation works better when
This looks so weird. All right, well, welcome everyone to the presentation portion of our program. So just as a reminder of how this is going to work, or maybe just a first description of how this is going to work. One team from each school has been chosen to represent the school in a 5-minute Shark Tank-like pitch. So the format is the team will present their project for 5 minutes to our esteemed panel of judges here. I think you guys have probably developed, 5 million products, give or take? Yeah. So look, first of all, let's thank our judges for being here. They're taking the time off of work. Their emails are piling up as we speak. Appreciate you guys being here. So after a 5-minute presentation, the judges will have 5 minutes to ask questions and follow up, and then we'll have some transition time between teams. Okay? And so with that, I would like to introduce, and I'm only doing first names for everybody because I'm horrible with names, and sometimes I can't even say my own. So we have, from down or south, we have Zach, Bobby, and Alex, and their team name is STEM. Is it EDU or EDU? EDU. All right, guys, you're on. Good luck.
That was a propeller car designed by a 6th grade student at Hillcrest Elementary School. But the problem is not many younger kids get to do things just like that. My partners, Bobby Sayer, Alex Soja, and I, Zach Mead, want to change that.
The problem that we decided to solve is the amount of engineers in our society is decreasing, especially compared to the need for engineers in our ever-growing infrastructure. In our community alone, there's been a 31% decrease in engineering students at both of our high schools, Downers Grove South and Downers Grove North. A significant factor is that students don't get the exposure at younger ages.
We talked to the teachers we worked with, and they said they aren't given enough resources to teach engineering-based concepts, thus leading to a deficit in the amount of engineers in society today. This could be detrimental. It could stop us from continued advancements in infrastructure, software, and even things such as travel. Without engineers, our society would crumble due to how much we rely on them.
So we started to think of specifications for our solution we wanted to design. We thought of things such as being kid-friendly, the materials that are needed to be affordable and somewhat reusable. We want it to be sustainable, so when we leave, it will go on without us. And finally, and obviously, we want it visually appealing and fun for the kids we're going to be working with.
So with these different design aspects, we finally decided on one particular solution. So this solution involves a kit alongside an app that goes onto the kids' iPads that can teach the kids the different lessons that we have in the kit.
So our kit contains the 3 most basic engineering ideas. We have electrical engineering, mechanical, and civil. Each kit has the amount of items to create a light circuit, propeller car, and a testable structure. It is then paired with the app, which gives a choice in which lesson the kids want to take part in. This lesson, after they watch the video, gives them the instructions required to complete the box.
Now, I know what you're thinking. What if students don't have the technology for our amazing app? Well, we also created a website. This website allows teachers to access all the videos, instructions, and even show the materials needed for each subject. It gives clear links on where to buy everything while also showing all these prices, as you can see here. They can also print out these instructions and give them to the kids as well.
So this website completely eliminates the need for these kids to have their own iPads. So this makes it more equitable and more sustainable in the long run, because this program can reach a lot of different schools, not just ones that have one-to-one programs.
We know you can't just take our word for it, but you can take the word from the 40 students that we went to. Last week, we went to Hillcrest Elementary School and tested our product with them and their 3 6th grade teachers.
Not only did the students love this idea, but the teachers did as well. Mrs. Donna Murphy afterwards emailed us with the introduction of, "We want to thank you so much for providing our students with an exceptional STEM activity this week." This email continued on by showing us a newsletter that they send out to parents, and the headline was our app and kit.
As you see from these photos, the students were almost always engaged, while also enjoying their time. We took surveys from before and after they created their very own cars, and the data was amazing. It shows that they were both more interested and excited about engineering afterwards. I'd like to personally share that 4 different students came up to me after and said almost word for word, "This is one of the most exciting lessons we've ever done."
But anyways, along with our idea, we have some interesting competitors. Competitors such as KiwiCo, a monthly subscription for a hands-on kit delivered to our house, or the Kids STEM Studio, an outside class for learning STEM-related activities.
Our idea is missing one thing in common that these 2 competitors have. It's a huge price tag. So as you heard Zach say before, our product here lists all the prices, and it's pretty cheap. It's about $8.53 per person.
As opposed to our competitors, which is upwards of $120 per kit.
Thank you.
Thank you for listening.
So it all comes in one kit and with all the civil, mechanical, and electrical parts. So you can build all 3 of these items with just one kit.
Yeah, definitely. So on our board, we have the initial cost alongside a reoccurring cost. So once the teachers make the initial investment, they can reuse some of the materials, and it's a lot cheaper than next year. So this can definitely be used multiple years in a row.
So the materials we use are pretty cost effective and cheap, and we can definitely buy them in bulk, is what we did. So for example, we have the Play-Doh. Everyone knows Play-Doh's popular with kids, and it's pretty cheap. You can get a bunch of them for a short price. And just using these easy to use, normalized materials that we have every day, like popsicle sticks, you can make certain things. Like this car right here has 4 popsicle sticks, uses 2 straws, and just a little motor.
We did, so we also thought of doing a coding part 2 with our app. So if we expand, we also want to expand out to the whole district of District 58, which is where Hillcrest Elementary is in. So if we do that, we can also expand our app or our kits to different engineering types.
Yeah, so we actually talked to the principal of Hillcrest Elementary School, which is where we went and tested, and she actually asked about the cost, and we explained the breakdown and the initial cost and reoccurring cost, and she said that definitely fit their budget there, and that they would be more than likely to pursue this project if it was offered to them. Yeah, so our engineering kits pretty much teach just very basic principles, like how a circuit works, and LED lights and like the structure of, so like for our civil, we kind of taught, with our introductional video, we taught like the basics of structure, you know, like how triangles are more strong than like squares and stuff like that. But on top of that, it's also like not so much the elements that we're actually teaching them, it's more to get them engaged and get them more likely to pursue it later down the road.
As of right now, it's just purely the materials, but considering this, I think it still would be very cost effective compared to the other similar solutions. As you can see, there's the Kids STEM Studio, which is around $60 to $120 per 4 classes maybe, and that's only for one kid, whereas all this stuff comes in bulk and you can teach a whole class of kids.
Team number 2, please. Good job, guys. Okay.
Thank you.
It works best if one of you talks at a time in the microphones. Good luck. Is there an extra microphone back there? Can I steal yours?
All right, judges all ready? Born ready? All right, well, welcome from Glenbrook South, collapsible water bottle keychain, Jacob and Clara. Good luck.
All right. So let's start this off by wondering, how does the average American high school get water in 2022? Well, let's use the example of Jacob. In 2019, Jacob always got his water from water fountains because they were still open, but due to the pandemic, they're now closed. So he started borrowing plastic water bottles every day, but at $1.40 every day, they started getting expensive, so he stopped using them. Then he bought a reusable water bottle, thinking it was more environmentally friendly. Then he lost it. Then he bought another one, but then he lost it again. So he just started to not drink any water throughout the entire school day.
So students' access to water has changed, and there's currently no easy, affordable, or accessible way to get water. So what are our options? As we mentioned before, water fountains, which have unfortunately been shut down due to COVID-19. And also, as our assistant plant manager at Glenbrook South put it so eloquently, water fountains are the most unhygienic part of the building, and he hopes he will never have to turn them back on because of how gross they are. So our next option would be plastic water bottles, as we mentioned. However, those are not very sustainable and could be quite costly, with about 91% of plastic water bottles ending up in landfills or in the oceans and just polluting the environment. And at Glenbrook South, they have an average cost of about $1.40, which buying 1 or 2 a day could add up to be quite a lot. And then finally, as we mentioned, the reusable water bottles, while they are cheap and sustainable, many students often lose them, and they can be quite bulky and difficult to carry around, so many students just choose not to carry one around at all.
Yeah, so what about the students that just decide not to drink any water throughout the entire day? Well, that turns out to be even worse. According to Healthline in 2018, even just mild hydration can inhibit one's ability to memorize things and their overall executive function. So there are 15 million high school students in America. If just 20% of them have a hard time bringing water to school every day, that means that there are 3 million high school students who are experiencing mild dehydration and may have a hard time focusing in class because of it. So that's where we thought of our idea, which is a collapsible water bottle keychain. Let me demonstrate this. So here's our product right here. So the top is able to attach right to your backpack using a key ring like our drawing here. So with the tap stays attached, then you detach the bottom. So let me just do that. Pretty simple using a rubber band. So this would stay attached to your backpack. And then it's a bit hard to see here, but in almost every American high school now, there is an easy H2O water bottle filling station right near the normal water bottle fillers. You might have seen these, you just use your water bottle and it's just right at the top like this. So for this keychain, use the same exact thing. So it unfurls like so into a plastic cup, and you would use it in a very similar way that you would just get a drink from a water fountain. But instead of taking it, you would just take a quick sip before school and then just go about your day. So then it just collapses simply like that. You can attach it again and then go on about your day. So we've tested this, and it still has a little bit of leakage, but that can be easily fixed, and we're working on that this week. So how did we actually do this? Well, we used a thing called a Yoshimura fold, which is actually used in a lot of aerospace engineering to collapse thin-rolled structures. This allows it to be very flexible, but still maintain its form while it's in a cup shape. Then we use CNC to cut out the wood parts as the top and bottom, and we use polypropylene for the sidings because it has an infinite fold quality, so it's able to fold down but then still fold back up into a cup.
So for our actual material, we decided to use polypropylene. As mentioned before, it's nice and simple and it folds as many times as we need it to. It's also food safe, so you don't have to worry about getting any sickness from using this. And then, as Claire mentioned, for the top and bottom, we just modeled these designs in Fusion 360, used a laser engraver, cut them out, and it was just some simple sliding them together so they create the nice, easy design that you see on the actual product.
And overall, these materials are under $2, so this could easily be implemented in any American high school for students that have a hard time remembering their water bottle during school. Thank you for listening. If you have any questions, of course, ask them. Thank you.
In terms of robustness, from an engineering perspective, have you given any thought to how you could possibly reinforce that? Because unlike a plastic water bottle or traditional reusable water bottle, there's no risk of collapse.
Yeah, so it was a little bit of give and take with the design. We made sure that it was small enough to be handheld. So ideally, you would put your hand around the cup, which I can actually kind of show. So instead of just holding it like this, you kind of put it around your hand, and that's going to be able to reinforce the design. And with the polypropylene and the Yoshimura structure, it's going to be able to have enough structure so you could just drink from it like a normal cup. Yeah.
So you have a very interesting design. I'm curious if you thought about how you'd make a large quantity of these.
So we definitely thought about that when thinking about the materials because we want to keep it cheap. With mass production, we haven't exactly looked into that yet, but it would definitely be using less of this jutting out side structures because you actually only need 1 or 2, so that would make it a little bit easier. Or actually, sorry, 2 or 3. Yeah.
What about cleaning? Can I put it in the dishwasher? I see it gathering just gunk around the normal school day. What are your thoughts about cleaning?
Yeah, so it probably shouldn't be put in a dishwasher, but you can probably just pretty easily manually clean it with just a finger, whatever you want to use, any scrubber you have in your house. It's you would just fill it up with some water, just rub out whatever gunk you get. If it gets in there at all, and then just like it'll probably clean it well enough.
How many, maybe it touched on what they asked earlier, a feel for how many open enclosures I can get on it?
It should be a lot. Like I said before, this type of plastic isn't that rigid, so it's not going to snap. It's called like an infinite fold kind of quality. So that means that, I mean, it's hard to know like how many, like, but it isn't for the foreseeable future that you would see it bend and then start snapping.
And the leaking you mentioned was from the tube to the base, not within the tube itself?
We've seen a little bit within the tube itself just because of the soldering job. That's just something that we're still fixing within the upcoming weeks, but it should definitely be able to be completely leak-proof.
Thank you.
So have you thought about some other markets besides the school user that this could fit into?
Oh yeah, definitely, because, I mean, how many places do you go now where the water fountains are shut off, you know, gyms, hospitals, pretty much everywhere. So we can see a pretty wide market beyond high school students, especially with elementary students who have even a harder time, you know, remembering a water bottle. I don't even know that many elementary school kids that carry a water bottle around. So yeah, that's definitely a market we could look into.
I'd be interested in it for hiking and camping, for
Oh.
example.
Definitely, yeah.
Did you look at any competitors on the market, and if you did, how is yours better or improved?
So yeah, we have looked into that a little bit. What we pretty much saw is that there are a lot of smaller collapsible cups in the market, but none of them have the truly transportable idea of having a keychain. So that's where like we really have like propriety in that, because we haven't seen anything where you could really attach it, especially for like a school setting.
Have you thought about scaling this up or down? Because what you have is a relatively small amount of volume of water relative to other water bottles that are available. So have you looked at designs bigger?
Yeah, so this is meant to just be used similar to a water fountain. You're not meant to really carry it around. So that's why we kept it smaller. It's also a little bit of give and take. The bigger you get it, the more it might start not being as sturdy or not being as foldable. So yeah, it's really just meant like, oh, a little quick drink before class, something like that. Thank you.
Thank you.
Team number 3.
Thank you. Oh.
All right, well, welcome to the Sixth Sense. J. Sterling Morton High School, we have Dave and Gennaro. Take it away, guys.
Hello, my name is Gennaro Barajas, and this is my partner,
Dave Alvarez.
and this is the Sixth Sense from the Morton East Engineering Group. Firstly, the problem that we want to solve is that many existing devices for the blind and visually impaired, while effective, are lacking in some forms of detection, so we're going to be making up for these failings of common visual aids while making less intrusive solutions for the blind and visually impaired.
While looking at previous solution attempts, we couldn't find any other product that was like ours. Many other products used cane attachments to find objects in the waist chest area, and with our hat, it provided a use of technology and light to detect obstacles.
So, after surveying a group of an estimated 60 students from amongst our class and year, we were able to see things, or rather, we asked them, though most of them weren't blind or visually impaired, to see things from the point of view of a blind or visually impaired person, because, well, of the lack thereof of actual visually impaired or blind people. We also took the chance to survey people here while they were looking at our project, and we came to find that people really think that our project is both comfortable and functional, which was also lining up with our survey results as the most wanted qualities in our product.
To explain our prototype, we used a hat that we purchased off a common retailer, and we used a LiDAR and Arduino components to make it work. For those who don't know what LiDAR is basically sonar, but with the use of light. And since it uses light, it's much higher polling rate and can get you more accurate results. In our hat, we used two LiDAR sensors and 2 time-of-flight sensors. We used the LiDAR sensors up front because when you move forward, it's technically, you move at a faster pace, and these 2 sensors can keep up better than the time-of-flight sensors on the sides. To let the wearer know that there's an obstacle, these are wired to vibrating motors that are inside the hat. The vibrating motors vibrate with heavier intensity the closer you are to an object, and thus letting you know that you have to do something in order to avoid it. Another limitation that we aimed to resolve was the fact that canes, since you tap them around on the floor, you can't see, or they can't detect an obstacle at a chest level, and that's why I angled the front LiDAR sensor at a slight angle to be able to detect these chest obstacles.
So moving on, launch for this product would really be feasible because of the short price point, or rather short price point for a tech-based object of $130. This includes things like our wiring, our Arduino Nanos, and other miscellaneous things.
Compared this to other solution attempts, we found solutions ranging from $25 a module, which would use ultrasonic, to a $700 cane attachment that would detect using sonar again in that same area, to a $4,200 text reader and object identifier.
For growing our business, really, we were thinking about expanding this to a wider audience, including but not limited to things like construction and other variegated categories.
Some of the project recommendations that, as we built it, we were notified of by the people who were testing it, was that one of the main things that the cane represents for visually impaired people is to let other people know that they are visually impaired, and thus giving them preference in like situations such as crossing the street, and this hat would not be able to show that they are visually impaired.
So that is the Sixth Sense from me, Genaro Barajas.
And Dave Alvarez.
Thank you.
You mentioned the vibrating motors. Are they directional? Like, would I know if someone's coming from the right versus the left?
The vibrating motors are attached, or not attached, but in the same direction of the sensor it is. So there's a sensor here, and there's a vibrating motor directly in the inside, and that's how they let you know what the direction of the object or obstacle is.
Did you do any testing on battery life?
I got the draws from all the components in the circuitry, and I used a 2200 milliamp battery, and it came out to be 24 hours of continuous run use.
One last question. Did you have an opportunity to put this on a blind person at all and have them try it?
No, we did not. But we did run some tests with a prior iteration of this with blindfold. So we weren't actually blind, but we did take away our sense of eyesight.
And how far out will it detect in front of me?
About 2 or 3 feet. And another thing is that it should be calibrated to the user's height, because since it points outwards, it creates a triangle. And for me, if a short person would wear it, it would keep vibrating if it was close to the ground. And up here, it wouldn't, because it's calibrated for me.
Is there any difference in size of objects? Say, hey, there's a dog that runs across, it'll pick up a dog, or it'll pick up a person on a bike. Is it?
It doesn't differentiate between objects. It's
But it
just
would pick up both?
Yep.
Okay. Thank you.
Did you do any, or make an attempt to do any type of market research in terms of the needs? What exactly for people who are visually impaired that a cane doesn't provide? You talked about objects at a chest height level. I'm just trying to understand with a cane, what types of objects would those be that this would detect that would provide a different element of warning for them?
Some of the limitations of the cane is that it wouldn't be able to detect low-hanging objects, like say something that's not attached to a floor, such like a table. It only gets attached to a floor like on very thin legs, so somebody walking up with a cane would probably not detect that with a cane. And this, using that angled sensor up front, it points slightly forward at an angle, so it will detect that chest area region.
And would you have any other way of attaching these if a person doesn't want to wear a hat? Is there another means that they could have this on?
We mainly focused on the hat, since that was our main objective, try to make it like a little bit sleek and not easily noticeable as a cane. But no, we didn't look into that.
How does your system handle like adverse conditions? So say it's a low light or you're in the rain. Were you able to do any testing in those kind of environments?
This is not affected by low light conditions, because the sensor emits its own light and it bounces back to the receiver and it calculates that time. So the hat produces its own laser, or like the light beam that it uses to measure. But we didn't do any testing in conditions such as rain or like those you mentioned.
Last question.
So I think I get how it'll pick up larger objects, the dog, the bicyclist. What about smaller objects, like just something as simple as I'm coming up to a curb as I'm crossing the street? Can it discern and detect when you need to step up and over a curb?
Originally, we were trying to completely replace a cane, but upon further development of the code, I found that finding those exact parameters were difficult given the time frame, and we decided upon that it would be best if could be possibly used alongside a cane as well, but it would serve as an alternative for those medium chest area heights.
Thank you, good job.
Matea Valley. Matea Valley, you're up.
Okay, everybody, welcome from Matea Valley. Arjun, who's going to talk to us about the putting mat.
Hi everyone, I'm Arjun, and today I bring you Pop Vision. So just to start off, quick raise of hands, who has ever played golf? Yeah, so a lot of people. And who here is good at putting? Who can make their putt every single time? Yeah, a couple people? Okay, you guys don't need this. But for most people miss most of their putts. They go home unhappy, have a bad day. But what our product here is gonna do, it's gonna make you happy, and it's gonna help make you make your putts. Putting is a fine motor skill. It's something that can be learned, and just through pure repetition, it's a skill. It doesn't matter how strong you are, how good your technique is. It's something that can be learned, and it needs to be practiced a lot and have pure repetitions. The golf market for these putting products is huge. There are thousands of companies, but none of them are really effective. Some of the products I've used in the past that I've enjoyed are PuttView, Putting Arc, True Pendulum Putting Sticks, and Sam Putt Lab, but there's always some sort of problem. PuttView is a $50,000 technology, and most people don't have the budget for something like this, or even have access to something like this product. The Putting Arc doesn't have any slope interpretation along with the putting sticks, and Sam Putt Lab, again, is a technology that's $7,000 that most people don't have access to. So where does that leave us? It brings us to Putt Vision. This product has a similar technology to PuttView, yet it's affordable and portable. Using this IMU sensor and inertial measurement unit, we're calculating the slope on the putting green before putting, and then those numbers and metrics are entered into our math and physics equations to produce an aim point. So once the sensor gauges all the metrics of the putting surface, this gimbal aligns a laser sensor to where your actual aim point should be. So similar to this PuttView technology, you can see there's where the person is putting and where the golf hole is. There's a direct line, and there's also an aim line. So whenever you have a slope and a putt that's not straight, you need some sort of aid that'll help you with aiming your putt. And what this does is it removes a variable so you can concentrate on just matching the speed and building muscle memory, which is what most people need when building a good putting stroke. My partner and I, who's not here today, spoke to 7 different PGA professional coaches who all believe that putting is the lowest hanging fruit and most easily conquerable aspect of the game. And yeah, using our product right here, we believe that you can fix up your putting game and drop many strokes while playing golf and go home happy. Yeah. Any questions?
So a simple question, did you take an average person and try to have them putt and then use any evaluation, have them use the product, a before and after comparison?
Yeah, so this technology actually exists. The part that doesn't exist is the portable, affordable version. So we've taken different people who play golf and don't play golf. We've took them onto this technology that exists, and they do enjoy the actual like PuttView technology. We're in a pretty preliminary stage right now. This technology that exists has taken years from world-class professors and people in the field to create. So it is a long process. We're hoping in the next couple of years, under using like professional help with higher level people in this field, we can put together a product that is portable. But it is challenging right now. We are just high school students, and the people have taken decades with world-class workers in the field. So we're still working on actually putting it together to get actual people to be able to test this.
And one follow-up question. So you've looked at a number of existing products with prices in the hundreds to thousands, several thousands. Where do you project this falling? How competitive is it?
Hopefully under $100. We are transitioning into using Arduino pieces, which are all commercial sensors. They're much cheaper than the actual prototypes we're using right now. And yeah, it's just a lot cheaper than what is currently out there and a lot more effective.
So is this device mainly to hone the putting stroke, or is it hone the putting stroke in the context of break and distance and undulations, all of that?
It mainly is to just build muscle memory and create a repeatable stroke, but it also does help with matching speed to your line. There are two aspects to putting, alignment and speed. To make a putt, you have to match both of them, and by removing the alignment part, now we're reducing the amount of variables. Now we're only changing one variable at a time, which is just the speed portion. So now we can build a repeatable golf stroke and work on speed. And once you're able to align both alignment and speed, then you can start making your putts.
So if I try this for the first time and I hit a 10-foot putt and I miss the hole by 2 feet,
Yeah.
what feedback do I get for the next time I putt to get my
well,
stroke better?
You're not going to get any feedback in terms of horizontal displacement. It just means that the speed and stroke length at which you're hitting the ball needs to be adjusted. This product only gives you feedback. It doesn't give feedback. It measures out the green. It gives you the alignment point, and that's it. Everything else means everything else has to be changed within your stroke. So if your putt is not reaching the hole and it's going too far, that means it's not breaking enough, which means you're hitting it too hard. So there are different things that the actual user needs to change in order to match the slope and the speed.
You mentioned portability a lot early in your presentation. Where do
Yeah.
I take this to use it? I take it to a putting green at a course. I set it up in my basement. Where do I take it to use it?
You can take it anywhere that you're planning to putt, indoor facilities, outdoor putting greens, indoor. There are so many different places that you can use it. As long as you have somewhere to putt, that's all that matters.
Thank you.
So if I understand correctly, this is using an inertial monitoring unit
Yep.
to pick up the green. How
Yeah.
does that accommodate for variations? So say you have a break right and then a break left. How does it pick that up?
Yeah, so right now, that's a good question, and it's pretty challenging to work into that, given the equations that we have. Right now, there are certain assumptions that we have to make in order to make progress. Right now, we're assuming that there's a uniform breakage pattern in the entirety of the putt, and then as we're able to conquer that, then we'll move into multiple slopes into a putt. We're not there yet. By using help, more professional help, we hope to proceed forward.
Would you still use, you think, an IMU or maybe a vision system, or what would be your thought
I
for
think
that?
we would have to move towards more of like a LiDAR approach, because just an inertial measurement doesn't give enough feedback for multiple breakage and breaking points. So, yeah.
Thank you. Nequa Valley, you're up.
It's over. Now he smiles. Yep. I'll take it. Oh.
No, we need three. We'll take you guys.
So we're going to have also one for questions. So you'll be down to 2.
Okay.
Okay.
Get one when you're done.
All right, so I'll give you 2 minutes, 1 minute, and then I'll give you a 10-second countdown. And when I'm done with the 10, you got to wrap it up. That sounds good. Did you hear that?
Okay, welcome Nequa Valley, Sachin, Peter, Connor, and Stephen, and they're going to tell you about the Stairlifter 2.0.
So really quickly, quick show of hands, who here knows anyone or they themselves have ever been injured while lifting a heavy object? Okay, so most of you. That's great. According to the CDC, over $225 billion in revenue is lost every year in the US due to injuries from lifting heavy objects in the workforce.
Every year in the United States, over 1 million people sustain shoulder and back injuries. This accounts for 36% of the missed workdays.
So you may be asking why we chose this problem in the first place. We wanted to solve a problem that we could all connect to personally. And lifting heavy objects up the stairs was something that I struggled with a couple months ago. I was tasked with lifting a heavy object up the stairs independently, but was not able to do it with my two bare hands. This is why we felt like we needed to come up with a solution to this problem.
Existing stair dollies are often centered around industrial use and are far too expensive and bulky for the average household. We wanted to create a design that focused on affordability, simplicity, and the ability to be used in a home while including our main function of traversing stairs.
So with these considerations in mind, we constructed the prototype as you can see here. The first design consideration that we wanted to consider in implementing to our design prototype was to make sure that it was easy to use for anybody of various heights. And in order to accomplish this, we made it so that the handles could be height varying. As you can see, all you have to do is simply push in the button clips and then push it to a height that you wish to see fit. The second design consideration that we considered in the construction of this prototype was to ensure that stair functionality was incorporated. To ensure this, we connected an axle between the two triangular wheel plates, 3 wheels on each triangular wheel plate. The axle around it allows it to spin and pivot. This allows it to traverse a staircase one stair at a time. And the last design consideration that we incorporated is to improve design safety, and this was incorporated using a Velcro strap that can be used to secure loads and prevent injury.
For our testing, we needed to ensure that our dolly actually reduced the amount of force people needed to exert in order to move their objects. To test this, we hooked up a force meter to the dolly and measured the amount of force necessary to move it across both flat ground and upstairs at various weights. We then compared these force values to the base weights of the objects and found that across flat ground, the dolly provided a 93% reduction in force necessary, and upstairs it provided a 32% reduction in force necessary. Of course, keep in mind that along with this force reduction, the dolly also allows our users to move their objects in a safe and controlled manner, keeping their back straight and reducing chance of injury. Though our design seemed simple and intuitive to us, we needed to ensure that this was applicable to the general population. To test this, we took 12 students from Neuqua Valley and brought them to a staircase and asked them to use the dolly with no further instruction. We then asked them to rate the dolly from 1 to 10 based on ease of use and their understanding of the design. From this, we got a score of about 9.2, indicating that our design was indeed easy to use and easy to understand. After our testing, we found that there were a few modifications we could make. We found that the majority of load on the dolly rested on this joint here, so we added a metal L bracket to secure and strengthen that area. We also found that while moving the object and turning the dolly, a lot of torque was placed on the triangular wheel holder. So we added 2 metal strips to each triangular wheel holder just to prevent any snapping in that area.
The last step in validating this prototype as a viable solution in the market is to look at a cost and benefit analysis. In order to do this, the first step that we had is to tally up all the costs of making the prototype, which is around $218. However, we believe that we can get this total dollar amount lower to around $126.59 using means of mass production, which would lower it to around its wholesale price.
All right. Finally, down the road, we would love to improve our dolly by using stronger materials such as steel alloys or carbon alloys, just so that it can hold more and help more people. We would also like to include extra reinforcements, such as these metal L brackets at the crucial joints. And finally, we would love to include a manual braking system just to increase the safety and security of our users. Thank you for your time.
So I've got to ask, what happened to 1.0?
We were just, 1.0 is kind of the typical dolly, and so we wanted to name it 2.0 as kind of our iteration of it and what we could improve on it, especially stair dollies. So.
Okay. Okay, and that leads into my actual question. How is this, I guess, improved over other competitor versions that are out there that maybe use a similar three-wheel design?
So a normal two-wheel design is not applicable for stairs because the normal two-wheel design will bump on every stair step. So if you have an object on the dolly, it will move. It can possibly fall off the dolly, or it can injure the person that's using the dolly. So we needed a tri-wheel design to be able to roll over the stairs properly and ensure safety of the user.
Okay, and did you have a maximum weight? Did you test for that, or do you know kind of what kind of weights it would be capable of?
We tested the weights a decent bit. We went around to 120 pounds in our testing, but we did not go further than that. And at that point, no cracks or breaks were appearing, so we're not exactly sure of the max weight, but we would guess somewhere in the range of 150 to 200 pounds.
Okay, is there any analysis you think you could do with this or maybe future materials to spec that?
Right, we were considering for like possibly like advancing the prototype to use almost like an aluminum cast version of a low plate. One of our main concerns in using plywood was that if you put objects closer and closer to this outside, the torque would be a lot more, the force it experienced would be a lot more, and thus it would be, probably break. That'd be the mode that would break from. So in the future, we were thinking about adding just an aluminum cast body for the the load plate. Also, maybe improving the wheel, the load rating for the wheels. Right now, I'm pretty sure it sits around 145 pounds per wheel. So that fits our original specification of having it hold at least 300 pounds. So the two wheels in contact on each side provide around 300 pounds on each side, 600 pounds total. But those can definitely be improved with either inflatable wheels or of those of the sort. But yeah, just using, in general, stronger materials could definitely help like increase the total load capacity.
How's the product perform going downstairs versus coming upstairs? About the same benefit or different?
Yes, so if you go slow enough coming down the stairs, it gives it time for that top wheel to kind of hitch back over and have two flat on the next stair again. We actually have a video here that shows going up and down the stairs, if you want to bring that over by them. And yeah, we found that if the stairs have a higher friction coefficient, it kind of hitches over easier going downstairs, but going upstairs, the material doesn't really affect it at all. And the video shows three different examples. A house example, the typical stairs that we have in our school that have kind of this rubber coating, and then one in our large forum room which has a carpet coating.
Is that how you injured yourself, was moving? What would be the first thing you'd change for a production unit?
One of the first things that I would change is we had to add supports onto the plywood underneath. I don't want to tip it over. You could kind of see it though, it's these two wooden bars down here. And that kind of restricts the load plate from getting down even with the ground, which would allow it to slide underneath those heavy objects a bit easier. And so if we were to do another iteration with better materials like steel for the load plate, it would be able to slide underneath a lot easier because we wouldn't have those support blocks keeping it from touching the ground.
You mentioned it being a consumer product. Do you have in your research, do you have a feel for how many homeowners have a dolly at all?
Not any that I know of. We don't have the exact statistic on that. That's something that we could look into the future. But we are fairly sure that there's a pretty big need for this in households.
We've also found that compared to traditional dollies, stair dollies are much less common in the household, so our product specifically goes for that.
Thank you. Oswego East.
How you doing?
Oh, do you? The three-wheel thing? I have seen those. Oh, I have a bunch of that too. Yeah, Steven. I did it for like a couple of
Yeah, and then you did it for a couple, and then I did.
So if you, when you're done, just look and see which judge wants you and just walk it over and start the handoff, okay? All right, so it works best if one of you talks at a time, although you all three have microphones, but if you all three try to talk, it just garbled, okay? All right, so this is on enough. I'll turn around to you. You're live, and
Timing, I'll give you 2 minutes, 1 minute, and then if you get to 10 seconds, I'll be once I get done, you have to wrap it up.
Thank you.
I get a microphone too.
Yep, Mr. Shetmeyer will give you his when he's done.
All right, welcome from Oswego East. Ella, Connor, and Juan, they're going to tell you about the Agua Deflector.
To start, who here has suffered from water damage to their phones? I know I have. Quite a few people. Currently, there is around 7 billion people in the world who have smartphone devices. And of those 7 billion people, there have been multiple accidents involving water. And as you can see from the graph over there, the population is only expected to increase, which means more accidents involving water.
So we have a few prior solutions listed. So we have 3 main ones, which is a phone case that surrounds the phone, making so water can't get in. We have a repair kit, and we have a bag that the phone usually goes into and seals it shut. So with the case, usually they're typically more expensive, and we're trying to make a low-cost product. And with the case too, a lot of times they can break, and even one small crack allows water to get in, and the product can't be used. And with the bags are typically one-time use. They are cheap and effective, but you can't be reusable because they typically break or they're just like toss and go. And with the repair kit, with newer phones, they don't typically work well, or they can mess with the phone's warranty, so they're not a viable option for us.
Yeah, so in order to have a good product, we wanted to have a lot of design requirements, just so we have pretty much a basis of what we want. The biggest ones was to have a product by today. I didn't want to come here with just a plastic bag and a phone and just call it a day. And then another one is we wanted to cover at least 80% of phones when this product is all good, which currently does work with the Velcro system we're going to talk about later. Another design requirement was age. We know a lot of kids nowadays have phones. My sister herself is currently 12, and she's had her phone for 2 years. And we all know little kids are a bit more dangerous with phones, so they can easily drop it wherever they want, especially like in the pool or if they're showering and have less music. Another one, if it's rechargeable, we currently are using a 9-volt battery, which lives around 4 to 7 hours, depends on what battery you buy. And it also has around an 8-hour recharge time, which is a little not ideal. That's why we're not sure about that battery yet.
And so we have our decision matrix down here, and we have 8 ideas that we came up with. So it's kind of hard to see, but for the May deadline and 80% of phones, those are our 2 main requirements. We have those multiplied by 2 just because our May deadline, so we can come here tonight. And for 80% of phones, we want to make it so it can be used with every kind of phone. And the roller idea, which is this idea that we have here tonight, scored the highest in all categories, and we decided that it's probably the best fit for us to do and with our ability.
And in the beginning of our designing, we actually did not include programming. We had this idea to have some sort of spring mechanism. We tried using a pen spring and a Nerf gun spring, but neither worked. So with our guidance of our instructor, we decided to go with the Arduino programming. And as you can see, our beginning testing wasn't working out, but after a while, we finally got the hang of it.
Yeah, so none of us had coding background experience, so this was kind of hard for us at the first. But then we approached some experts in their field. We have a electrical engineer, Diego Martinez, and also a computer engineer, Dr. Amanda. They both really helped out. They really gave us a basic code and where to start from there, because we all really had no idea what we were doing at the beginning. But we really successfully made a code, which currently we have right now, if you guys want to check that out later. and it really works well now.
And so the final piece was putting it and assembling all the pieces together. So our main idea was to cover the entire phone with a seal, but with the time and constraints we had, or we had a lot of people out, including our teacher, that we can only make it so it covers the front of the phone and based on our budget. So on the back, we used a Velcro system that go on the back of the phone case. So this way we can adjust any piece that we need to, so it can fit on smaller phones or it can fit on bigger phones. That way it can go on 80% of the phones to fit that requirement. And so we have the water sensor, the Arduino, the battery, and we have the motor right here holding the plastic sheet. So this is all kind of hard to fit, so we made it so it's adjustable and it can be moved around.
So we did a lot of testing at the start, but I think this is the best successful product we have. So thank you for listening. Also, if you guys want to check out the back closer.
Can you make it run for us?
Yeah, we can do that. So basically the first step is to roll the sheet over and put it under the motor, so it's like putting pressure on the top. And then once it's done, we can plug it in, which activates everything.
And we do have numbers for this. Ideally, it works 80% of the time of our tests, so it's obviously not a perfect number, but at the start, we are happy with it.
While he's doing that, I have a quick question. So did you do any comparison of what you thought where this would come in cost-wise, price-wise, given other solutions in the
Yeah,
market
so
currently?
most of the solutions that Connor listed are around $30 to $40 on Amazon plus shipping, unless you have Amazon Prime. We had an $80 budget. We only used around $70, but we still have a lot of materials left. For example, we still have like 3 to 4 water sensors that came in a package of 5, and we ideally want to put it up to sell like around 20 to 25, which we believe is very affordable, and we can make a lot of different prototypes with that amount of budget. What test?
So basically you roll it up, so we're having a problem because one of the pieces moved a little bit. But basically the motor holds it up in place. And so once the motor's in place, all that's left to do is put water on the water sensor, and it moves. And if it doesn't knock down the first time, it should keep moving and then knock it down. But since the motor did move a little bit, it got out of place and it's hard to adjust. But what it's supposed to do is supposed to push like that and fall and get magnetized out to the bottom to cover the phone. And then the final piece is once it's dried off, the motor goes back into its original position so it's ready to be reused.
And ideally, I know it looks a bit big right now. We originally, when we first set up our Arduinos, we didn't really know like the difference between all of them. So when we got ordered this one, it was obviously bigger than we expected. But we want to thank the 6 Sense group actually, because they let us know of a new Arduino that we can use later. It's way smaller. He said it's around thumb size, so it can really effectively work and be better for all other products.
Can you give us a brief overview of the points on why something like this is better than just a static case that's waterproof?
So with static case, usually like I said, one crack can be devastating to the case, and also it's more expensive. Getting a good quality case can be up to upwards of $80 to $100. This price point is meant to be reusable, $20 to $25, and so it'll cover the whole phone. And it's also, we don't want to infect the user's ability to use the phone, so we have it so it's a passive type of case, so it's not in the way. Right now the prototype is a little bigger because we had time constraints, but ideally it'll be a lot smaller, a lot more sleek, so the user can actually use their camera, they have the passive protection without even noticing the case is there.
Thank you very much.
Can I have Oswego High School? Yeah, I got to tabulate all the voting.
Oh, for the,
Yeah,
was there that many votes?
yeah, 900.
Really?
Yeah. Wabanzi. Yeah, Wabanzi just.
I have figures.
Yeah.
This looks interesting.
What's that?
Yeah.
Okay.
Fine, you got
Take
some
your time.
We have 5 minutes.
That was trained on that. You guys got in here early without a camera. Leave this for your partner to
Sounds good.
here, right?
Yeah.
Okay, well, welcome from Oswego High School. Ben and Ethan, they're going to talk to us about intelligent track pacing.
Okay. Hello, my name is, thank you. So my name is Ben Huey, and I run on the Oswego track and cross country team. And as you can see, hopefully, in a second, my partner will be running in and demonstrating our cones. His name is Ethan Forcell. He's Athlete of the Week at Oswego High School. So, as you see, we have a starting timer, and he's following the lights.
Hi. Uh-oh.
You're so fast.
I'm too fast.
For you.
Okay, so we're both runners at Oswego High School. We've been running for a very long time. And one thing we noticed in running is the biggest challenge to being a fast track athlete is pacing. It's a skill. It takes a lot of practice to be really good at pacing. Getting on the track and having your coach tell you, run a 68-second 400. Not everyone can do that.
So, some previous solutions to this problem, this is a very old sport, is there's the stopwatch and a running watch, right? And both of these fail in one way, and that's where your mentality comes in behind this. Mentally, when it comes down to running, you want to just be focusing on hitting the time that you want to hit, because that's as you improve. That's how you improve as a runner. So when you're 200 meters in and you're told that you have to run, that you just ran a 30-second split, and you need to calculate that for 1,000 meters, that takes your head off of the extra running. Now you're focusing on doing math instead of focusing on getting out there and doing the work. So we decided to make this technology. It's all good. We decided to make this, which is basically, would you like to explain? Yeah.
All right, so what we have here is just they're just cones. They have built-in lights. So there's two lights, it's blue and green. And all you do is you follow the green light. So the green light's gonna go cone to cone to cone to cone, and the blue light's gonna be trailing behind it. So as long as green light's in front of you and the blue light's next to you, you know you're on pace. If you see a blue light in front of you, you're behind pace. If you see no lights, you're probably going too fast or like horrendously slow. You want to explain how it works?
So basically how this works is there is a chip inside each cone, and this is where I did most of my work for this project. I did all the programming for it. So the chip is an ESP32, which is programmable with Arduino software, and basically it has all these chips have addresses on them, and each one will talk to each other in a line, which is really cool because now you can add as many cones as you want to, and however many you want to. If you want 20, if you want 10, and yeah, that's basically how the software works.
The hardware is not very complicated, I'll say. It's just a PCB, printed circuit board, and that's just hooked up to the pins on the ESP32. It's got a 3.7 volt, 750 milliamp hour battery, which isn't huge, but it's going to last 2-3 hours being used pretty much continuously. And that's plenty to get you through a track workout. The entire track practice is not that long, so if you have it run and charge it before every workout, it's more than enough.
Yep. So when we bring it down to cost, this watch I'm wearing right here probably costs around $300 to make, or to buy, which is a running watch. For 20 of these, it costs around $180 to make. Already in itself, if a track program wanted to buy this, it's already cheaper than an individual buying a running watch. It can really be meant for anything. Another benefit of this is that it is portable, as you did see before. You can bring it wherever you want with you, whether that's a track or a soccer field or anything else. Anything that you need a timing system on.
So yeah, $310 for a whole system, make 20% profit. It's a pretty good deal, actually.
Yeah, thank you.
Thank you.
So did you do any comparison with existing products out there that are used for training today?
So when it comes down to the products out there, really most options used by amateur athletes are either stopwatches or running watches, which when it comes down to it, you have human error. You're doing math in your head, which just affects it. You can't confirm that you're going to do it. With this, all you're doing is looking ahead of you and just focusing on form. The product that came before this that gave us a lot of inspiration for this was this wave-like technology, which is basically a $30,000 ring of LEDs that go around a track. And as you can see, that's very expensive. But that technology has been proven to work because that has been breaking world records. That has been lasting 15 years, and this was all done last year with this technology. So we wanted to make something that any athlete could use, which this gets to it.
And then one more question, did you consider, obviously this isn't just for indoor use, you're looking outdoors, you guys consider environmental effects about designing something that's more robust, or at least able to withstand the elements? Because sometimes it rains on track people, as you guys probably know.
Yeah, so these prototypes, yeah, don't leave these in the rain. But I'm sure if you got like a solid, like injection molded piece of plastic, and you did a better job than I did lining the insides, it wouldn't be too hard to make it waterproof. And I'm sure they won't blow away. But some days I think the winds are just crazy.
So is there some radio technology, cone to cone, some type of mesh network or something going on here?
Yeah, that's exactly what it is, the mesh network. Basically, each one has an address, and each chip basically talks to the next one. So when it receives data, it will talk to the next one and send data to the next one, and it can go wherever it wants. So it's pretty cool. It has about a 100-meter distance where it can go, so you can spread these out really far. Yeah.
What does the power budget look like per cone? To reference his earlier question about outdoors, like could they be solar powered?
I'm not entirely sure. I don't think solar panels are going to be quite efficient enough, especially on a cone this size. You might just want to keep it on battery.
Can I program my distance or pace with an app, or I plug it into the laptop first, or how does that work?
So at this moment in time, we just, there's a variable that's being sent to each one. So right now I have the delay at 1 second in between each cone. You can change it to that, but
Yeah, so the ESP32s, they are compatible with an app, and that's just the next stage in development.
Okay. Did your whole team, you guys mentioned you were on the track team, I believe, did your whole team use it, or just the two of you?
we have some videos right here. I don't. Yeah.
Yeah, you're not going to see those very good. But
Yeah, but we did test this out. Our coach used this for us, and it has been tested. So we didn't do like a workout with this, but it did work when we tested it at that distance.
Our coach was a big fan. You know, in one of our videos, you can see him. He goes out too fast and he adjusts his pace, do the lights and stuff, and we know it works, and it's kind of fun actually, if you like running.
So is there a limit to the number of cones you could have theoretically in one system?
Theoretically, no, because it's a chain. So each cone will talk to the next one. So as long as they're not super far apart from it, you could just do an infinite amount, and you can even have it loop around. You can set it up for as many loops as you want to. So right now it's on an infinite loop, obviously, but if you wanted to do like 2 loops around the track, you could do that as well. So yeah, you could really have as many as you want or as little as you want, which is also really nice for the pricing as well.
Okay, and have you tested them outside at all, like the visibility? I know if it's really bright out or maybe it is really dark out, are they still easy enough to see?
Right now, the LEDs aren't quite strong enough. That was one of the challenges we're working on. Inside they're pretty bright, and if you really look at them, outside you could probably make it out just fine, but it's not ideal yet.
Okay, and what are the benefits of having, like right now you said they're daisy chained together, each one communicates with the next. What's the benefit of that over having them all communicate to maybe like a laptop or a central hub?
All right, that's actually a great question. A 400-meter track is actually kind of big. It's just a straight 100 meters plus however much for the turns, and the range isn't enough. So daisy chaining, the cones are going to be fairly close to each other, assuming you have at least 4, which ideally this is only useful if you have at least 4. So that's really so the daisy chain it keeps everything going in range.
Thank you. St. Charles East. Thanks, guys. Good job. It is. Yeah. Love the intro. I want to see you guys run that fast. After you.
No. Is there a bear? Oh.
No, two.
More.
Yeah. I couldn't remember. And then you're taking me out for dinner, right? No. Are you sticking around for dinner, or you guys?
I'm sticking around.
Yeah. Okay. You got kids going? Everybody else staying? You guys?
No, most of them. Well, half my team had to go. Half my kids had to go to soccer, volleyball.
I was.
I know. Well, I didn't feel bad because I looked over to this side of the room and there's people getting ready.
Take your time. Okay, so this microphone here is a little wonky if you're shaking it or doing things that'll make you hear popping noises.
Okay.
So be careful with that, okay? And there's any microphone feature here. Okay, Mr. Tetmeyer, when he's done introducing you, will give you the microphone. All right, some hints. Don't all talk at once into a microphone. So take your time and one person at a time and keep the microphone a certain distance, consistent distance from your face, okay?
Thanks,
When
Louise.
you're done, look to see who has a question. Hand the microphone to one of you.
Okay, from St. Charles East, welcome Gabby, Clara, and Caitlin, and they're going to talk to us about medication management.
Have you ever forgotten to take your medicine, if you've taken your medicine, or where your medicine is? We know we all have. So what we wanted to do is create a solution to that problem so that everyone can take their medicine easily and make sure that just their daily life is simplified. So we found in our research that 50% of Americans that are prescribed prescription medicine for chronic illnesses will by a couple months later not be taking the correct dosage or not have a consistent routine with it. This leads to billions of excess spending for both hospitals and for patients, and leads for more excess health reactants for the patients. So we at St. Charles East wanted to create a solution to that. So I'm Gabby Del Santo, that's Caitlin Schroeder, and that's Clara Owen, and we created the medication management box. Our objective was to solve the daily struggle of keeping all of your medications in check. We all know that there doesn't need to be any more stress added to daily life, so we wanted to make something that can aid you in that. Our product is more useful than the current products on the market because, as you can see on our board here, current competitors are not very user-friendly. They are either specifically only on your phone or they're only a physical product. And in our technology integrated world, we need a bit of both. So we have an audio-visual display that makes sure things connect there, and it solves kind of two of the most common issues in current solutions.
So we designed a device that would fit our specifications. Those included a box that was custom made to be able to fit perfectly on a counter without being in the way. We also wanted to make sure that the box was easy to use, meaning especially that it was easy to get into because again, we had issues with this model being very, very difficult to get into and some meds just flying all over the place. We wanted also to be able to have three times a day to take medications and of course 7 days a week. And we needed to have lids to easily separate and keep everything clean. And we also used an LCD screen to be able to display the time of day, your name, and the medication you needed to take, so that way it was very, very clear to whom the medication belonged to.
So first, the device will ask you your name, which will be used at every reminder time. It will remind you of It will say your name and then remind you the time of day, the 3 medications that you can put in for the time, and also a buzzer will go off at the same time until you hit the button and the buzzer will stop. The three things you can do to this device is you can add medications, you can change the time of day, and you can also change the times that you want to be reminded. This user-friendly and streamlined experience will make it a lot easier for people to take their medicine effectively and independently. So in order to measure the effectiveness of this design, we would have 10 plus unbiased people in each a control group and a product group. The product group would be using this device, and a control group would be using something similar to this. They would be measuring the scale of ease of use and the amount of medications missed over the course of a week each. Due to logistical and time constraints, we unfortunately were not able to go through with this. However, if we did, we would be looking for the minimum amount of times missed counted throughout the week, and we would also be looking for the highest ease of use and positive comments.
Now, of course, you may be worried, what's the cost of this device? We used Arduino parts and 3D printed plastic, which are both very, very inexpensive. However, another alternative would be to use a more eco-friendly alternative like silicone or biodegradable plastic. But overall, with our current model, it is between $50 and $60 to produce, which is a big improvement from the trillions of dollars that are wasted due to medication mismanagement in the healthcare world. So this is very much an efficient way to reduce waste and cost.
And as always, our goal throughout this entire project has been to help people. We all have personal and familial connections to people who have to take medication. And even when we were doing our table presentations earlier, we had many people come up to us talking about friends and family with Alzheimer's, or for my personal experience, my grandma has to take a lot of medication for her arthritis. So these are all ways that we can help improve the daily lives of people and people that they love. We have many future plans, but thank you, and do you have any questions?
It looks like you have two prototypes there, a very refined one that's up on the glass pedestal, and another one. Can you talk about the learnings or experience to go from A to B?
So our first prototype is made out of pretty much a fancier version of cardboard, which we were able to use our laser cutter at school to be able to cut out. When we ended up finishing this, however, there's a lot of soot all over the prototype, so we wanted to minimize that because that's obviously a very, very large concern because there are going to be medications being put in here. Also, with the different slots for all of the Arduino parts, we're not in a good spot based on like what we were able to configure with the wiring. So when we went from that prototype into our final one, we decided to 3D print it, which was not our original plan, but we agreed it was going to be the best idea. And then we changed around a couple of the placements of the Arduino parts so that way we could easily make the wires reach and still have them in the relative area that we wanted.
Two more quick questions. It looks like there's a portable capsule, so if I'm going to leave for the day, can I take my noon medications with me?
This right here, or?
The little, yeah, that.
This is one of the lids that goes over the compartments.
Okay.
So that way they're protected and not like open to like the air and all of that stuff. So this is just an example of what these look like instead of just looking at them sticking out as they are right now.
And is it, you mentioned it's sitting on a countertop, is it at all, any provisions within it for child-proof if mom and dad have medications in this and the kids, can it keep kids out right now?
That is part of our future plans to be able to create some sort of locking mechanism so that way the medications are a little bit more protected from other people who might like try to take them or from people trying to take them at the wrong time. So overall, like a locking mechanism would be part of our future plans.
Thank you.
So what's the one feature in your design that's just hands down better than anything else on the market, whether it's a usability feature or something else?
I would say that our biggest plus above our competition is the LCD screen. It really just makes the entire experience more customizable. There's a big issue in our healthcare system right now, even with things like doctors, where our healthcare system is very like rustle and bustle. So if we're able to customize it, it'll just make it that much more personal, because we know people won't care about things if they're not personalized. So I think it just ends up helping create a more conducive to actual humans instead of just a little orange pill bottle that sits on your counter. It creates more of a attachment to taking your medicine and doing it consistently.
What were the source or sources for the statistics you provided and are on your board?
Yeah, so we used an article by the New York Times to start off with, and then that led us to articles in the New England Medical Journal and some by the CDC, but the New England Medical Journal was really a big one in what we were using, just because it had the most straight facts, whereas the CDC was more of a summary. Same thing with the New York Times. So yeah, those were our big sources.
And you mentioned you were trying to do a study with a control group, but you didn't get to that point. What do you speculate, though? People who use this commonly, or elderly, or in a different state of mind, they might be technophobes. They might be scared by that as opposed to a simple plastic box. How would you overcome that with that, given that demographic?
Yeah, Claire, you want to take it?
So I wrote an instruction manual. Basically, it will tell you the 4 things you can do with it in very short terms. This will be given every time somebody has one of these, and hopefully they will be able to read them. Also, like any contact information could be sent out. Also, yeah.
Last question.
Okay. How does your product actually notify someone that it's time to take their medicine?
We have a buzzer, so it's like an actual physical alarm. So think of an alarm clock, but with an actual visual display too. So what it will do is, if you have it like hidden in a drawer or something, I have ADHD, so if it's in a drawer, I will forget about it. But what this will do is it'll actually keep beeping until you pull it out and you press the red button there. So until that happens, it will just keep beeping and keep reminding you until you actually do the thing you're supposed to do.
Interesting. Thank you.
Yeah.
Thank you. Well, Bonzi, you're up next. Wabanzi High School. Somebody shake them awake. From your mouth, talk in a clear voice. You're turning your head away from the microphone, it won't pick you up. Got it? When you're, Mr. Tetmeyer, after he introduces you, is going to hand you the microphone, so you'll have yours. Make sense? When you're done, look at the judges after your 5 minutes Look at the judges, whoever has their hand up, just drop one of the microphones with them, okay? Got it?
Yeah. The other two I tracked.
Okay. All the guys, I'm gonna say all 4 names, but I'll let you introduce yourselves after that. All right? You ready? Cool. Board ready?
All right, number 9 in your programs, number 1 in your hearts, the last of the valleys, Wabanzi Valley, and they're going to tell us about Auto Bloom. A team of 4, we've got Jeremiah, Elijah, Evan, and Dev, and I'm going to let these guys tell you who they are.
I'm Evan Fleming.
And I'm Dev Ganesh Reddy Rami Reddy.
So, around 60%, 66% of all households in America have a plant, and even more than that, around, let me see here, 7 in 10 millennials call themselves as plant parents. And the unfortunate factor is that a lot of these plants end up dying due to terrible care, basically. And what we wanted to do is make a product that can help solve that issue with Auto Bloom, which would help automatically water the plant and keep track of exposure to sunlight, humidity, temperature, and the soil quality while also continuously watering it.
So, real quick question. How many of you actually have a plant at home? Many. So, next question. How many of you have killed a plant? Many. Okay. And there are so many reasons for this. A lot of plants, many plants require different types of light, different amounts of water. There's so many factors, and not all of us have the time, energy to actually educate ourselves and learn about them, and especially take care of a plant. And that's the case for me. My mom gave me a small plant to take care of, and I can tell you, I water it, I dump a bunch of water in it, like once a week. Very unhealthy for a plant. I'm not sure how much sunlight it gets. When I go to sleep, I close my curtains, and when I rush to school, I forget to open it sometimes. So it's very hard and very easy to kill a plant, yet plants are very effective at home and in the corporate world. They boost productivity by 15% and reduce stress levels also by 15%. And almost all of us are going to own a plant one day in our lives, and I can almost guarantee we're all going to kill one too. So how do we reduce our murder rate of plants? And this is where Auto Bloom comes in. And because we have our own issues, we specifically designed this to address those issues. Primarily, we decided to make this IoT capable, Internet of Things. This is capable of connecting to Alexa, and you can water your plant from anywhere in the world just by turning it on your phone. I could be in like Greece, Europe, whatnot, Asia, and I can turn it on and off from my phone. I can ask Alexa to do it. In addition, because it's connected to the cloud, you can see your water level, soil moisture, humidity, temperature, and all of these parameters are set to your specific plant. So what that means, let's say you have a cactus. You come home, you tell Alexa, hey, I got a cactus. And the system will calibrate all the sensors to that cactus. It'll water that cactus maybe, because a cactus doesn't need that much watering, so it'll give that amount of water. And it'll help you place it in the right amount, right area. Some plants need shade, some plants need more sunlight. And it'll help you adjust so your plant gets exactly what it needs. And essentially, it's very low maintenance in the sense all you have to do is refill your reservoir, which is adjustable, by the way, every couple months. And it's battery powered, and because it's low voltage, and the chip can completely turn off, so it's not constantly using power. The battery can last upwards of 6 months to a year, so very low maintenance. Your plants are going to stay alive. And do you have anything else to add?
No, I mean, you made it perfectly with being able to change the size of the reservoir with having this piece that's in the middle. This is where all the electronic pieces would go into, so you can easily just retrofit it for whatever size you need. So you can make this as big as you want, and you just need this amount of space for all your electronic needs.
And what that does is you can use just that one piece of tech, and you can design any size reservoir you want. So you're not buying a whole new device, you're just buying some plastic, and that any size, and we've designed it so you can make it for bigger plants, and you can have a bigger reservoir if you want to water more plants. Let's say you have 10 of the same type of plants. With the tubing, you can connect this from that one piece of tech to 10 plants, and you can water all of them. And that's pretty cool. And one last thing we want to add is we 3D printed this, and we found it to be really effective in the sense that we can experiment with colors, designs. Like this one sort of has a little diamond pattern. And why we really like it is it does add to the aesthetic value of a plant. Like you don't want all that text showing. And so you can customize your colors and we can print it out. And if you have dimensions in the future, right, anyone can ask what they want. It's printable, what colors, so it can match their plant. And we feel like this is very scalable and a lot of people would love this. So that's all. Thank you.
So does your product have a plants of the world database that you would have to develop yourself, or is there a readily available plants of the world database with all this?
So we would look to develop one ourselves, but there are similar platforms out there called Planta or Blossom. These are available on iPhone and iOS. They charge a subscription, but you could search up the plant. The app tells you how much water you need to water that plant, how much sunlight it needs. It gives you all that data. However, it doesn't do it for you. There's still user input. And with our product, it would take that data, it would send it to the sensors, and the user input isn't required. It would water itself, and that's the main difference.
How would the system make adjustments so that plant looks like it's in a 4-inch pot? What if I put the same plant in a 12-inch pot? How much water do I put in for the different size containers?
So when you get a different size container, we're assuming you're getting, a bigger plant or a different plant. If it's the same plant, the plant will still need the same amount of water, the same amount of sunlight. You're not changing too many of the parameters. So when we say a bigger size or a bigger reservoir, we're assuming you're getting, maybe a small tree or something and you need something bigger. Or a bigger reservoir if you have multiple plants.
Besides the water tube that's feeding in there, it looks like you have some kind of a sensor. Can you, in quick 30 seconds, like what is that sensor and how does it hold up to the moisture and anything else in the soil?
So we have a soil moisture sensor, and this helps control how much moisture, it tells the system how much moisture is in the soil, and it helps the system see if it's overwatering the plant or underwatering the plant. So, and most plants are killed by overwatering and underwatering, and so this helps the system give the optimal amount of water to each plant.
And how are you sensing if it's getting enough light?
There's a light sensor, and we might implement a UV sensor in the future, but this light intensity sensor basically helps us place it in the optimal position. So like we said, some plants need more light, some need shade, and based on that parameter, when you tell the system what kind of plant you're using, it would inform you, hey, this is too much light, move your plant somewhere, with more shade.
How much research did you do into existing products, whether it's something as simple as a water gauge that you're in a sun sensor that you stick in that a guy like me that kills plants uses, as opposed to a smarter product like this with an auto feed feature?
Well, when we looked, we did find some other watering products. However, they're on a timed system, and they don't come with a reservoir. They don't come with a tag. So it's more of an aesthetic feature too. You have to have a bucket of water next to that. So here we really try to make it aesthetically valuable and try to hide all that tech. So the way we've presented it now is you can see the tech because that's what we're presenting. But I guess for most people, the tech would be in the back and you just see the plant and what it's on.
So what parameters does this all track? What are you all sensing?
Could you repeat that question?
So what kind of parameters are you sensing? So temperature, humidity, anything else?
Yeah. So we're sensing the amount of light hitting the plant, the temperature and humidity, and the soil moisture. All big indicators in plant health. One more sensor is we have a water level sensor for the reservoir, and that basically will inform the user when the water in the reservoir is running low, send a notification, and remind them, hey, you need to refill your reservoir.
Are you able to view that information remotely?
Yes. It's all in this app, which, you guys want to go through. Yeah.
Yeah, and the only other question I had is, did you test it with multiple plants or multiple soil types?
We did not get that far. We did test it with 2 plants, one being this and another being a yellow flower, and both plants have survived and they were locked in a classroom. So for us, that's promising. But I think with more time and, there are obviously some things we'd like to add to it. So I really do think we can get some promising results.
How long did you test it for on those 2?
The yellow flower, approximately a month and a half before we moved on to our next prototype. As you can see here, we have 3 different, designs we're playing with. And so this recent one, about 2 weeks.
Thank you. Hang on before you go. So we're going to, at 7 o'clock, the awards will start. So if you can be back in your seats about 6:50, then you'll be ready for the award ceremony. All right. Go enjoy dinner. We'll see you soon.
There you go. Thank you. Good job.